The Smart Emissions Reducer interacts with the crankcase vapors present in both gasoline and diesel engines as PCV and CCV gases. It decomposes and ionizes the heavy hydrocarbon elements, thus converting them into a light combustible hydrocarbon medium capable of promoting a more rapid and thorough combustion within the effective crank thrust angle of the power stroke. Crankcase vapors consist of blow-by gases and aerosols of heavy oil vapors generated through windage activity. The heavy hydrocarbon elements in a liquid aerosol form are unable to contribute to the combustion process and mostly cause carbon buildup in the engine while elevating exhaust pollution. Using dissimilar metals to form a functional cold catalyst, the Smart Emissions Reducer fractures these large hydrocarbon molecules by extracting the common bond electrons. This results in smaller molecularly sized HC elements with many ionic charges. These lighter ionically charged hydrocarbon clusters are able to speed up the flame front to convert more of the chemical energy in the fuel to kinetic energy at the flywheel and emit less toxic emissions into the atmosphere.
Wait a minute! I got a better idea. In an engine, there's only so much time for fuel to burn and make power. Beyond this magic window, burning fuel just heats up the coolant and exhaust systems. The Smart Emissions Reducer converts normally harmful crankcase vapors into something more like a quality fuel. You know, kind of like an additive. To show how this process can improve performance, reduce emissions, and improve fuel economy, let's cook up an illustration. To show how this works, we'll use two identical charcoal grills. We'll use the same amount of charcoal and lighter fluid in both grills. To one of the grills, we'll add a combustion accelerant, gasoline. Gasoline burns at a much faster rate than the lighter fluid, much the same way the blow-by gases in the engine do after being modified by the Smart Emissions Reducer. We only need a tiny amount of gasoline. We don't want to use it as a fuel, just a combustion accelerant. Now it's time to fire off the spark plug. Can you see the grill with the combustion accelerant is really taking off, while the normal grill is still working on what we call flame propagation? We're getting a nice, even gray color across the entire surface of the grill with the combustion accelerant, while the normal one is still working on getting things burning. Okay, now the exhaust valve opens and whatever hasn't burned becomes pollution. It doesn't take a scientist to figure out that a combustion accelerant will improve performance and mileage while reducing exhaust emissions. This means you can go green with the same machine.